An object represents both a value and a set of operations together in a single entity. So here's an example interface of a stack object. So the operations are given here, and they are invoked all on the same object. So everything is in S, and the stack's value is stored inside the object S as well. So here's an example use of it. I create the object S, and then I do a push A operation on S, then I do a push B operation on S, and finally I do a pop X operation on S, and I display the result. So all the operations are done on the stack objects. So here's the implementation of the stack object. So right now I'm just going to give you the implementation quickly. In the next lesson we're going to go much more in depth on how this implementation has worked and the decisions making it. Here, let me just explain the implementation as follows. We have the three operations, push, pop, and is empty. We have the state of the object, which is stored in a cell, and we have a one argument procedure which does dispatching. So given the operation, which is called the message, it uses a case statement to pick which operation, which procedure to call. So each call to this function new stack will create a new stack object. The object is represented by a one argument procedure. The procedure does what's called procedure dispatching. That means the procedure has a single argument that represents the operation, and it uses a case statement to pick the operation to execute. And finally, the encapsulation is enforced by the cell being hidden using static scoping. So that's the typical way that objects are implemented. So let's compare briefly the stack as an abstract data type and the stack as an object. So here's the abstract data type implementation using the secure wrapper, and here is the stack as an object, but here it's represented as a record because it's very short. It's almost the same as the previous one, except that the call is done using the dot operation of records. So here again we have the three operations. Push pop is empty, push pop is empty. The new stack operation corresponds to here the new stack function. In the other one, the cell being hidden by static scoping corresponds to the wrapper unwrapper, which hides the information when it leaves the scope and comes back into the scope. So in fact, it's possible to implement any data abstraction as either an abstract data type or as an object. So the example I give here, you can in fact generalize this. So let me just make a few more comments on objects, since the next lesson will be completely focused on object-oriented programming. So first of all, objects are omnipresent. They're everywhere in computing today. The first major object-oriented language, though, is very old. It was introduced in 1967, and some of the basic ideas even existed before that. The fact that you want to encapsulate data and the operations together. So Stimulus 67 directly influenced a language called Smalltalk, starting in 71, and C++ starting in 1979. And through these two languages, most modern object-oriented languages have been influenced by Smalltalk and C++, and through them influenced by Stimulus 67. But in fact, object-oriented language is kind of a misnomer. Most modern object-oriented languages are in fact data abstraction languages. They have both objects and abstract data types, and they include other concepts, other forms of data abstraction such as components and modules. Okay, that's all I want to say about objects for now, since the next lesson will be completely devoted to object-oriented programming.